Students, coming to the next application in backtracking, that is the Hamiltonian problem. So we call it also as Hamiltonian circuit problem. So what is this Hamiltonian problem? This problem is concerned about finding Hamiltonian circuit in a given graph. So whatever a graph they are given, for that given graph we have to find out the Hamiltonian circuit. Then what is this Hamiltonian circuit? What we call this Hamiltonian circuit? Hamiltonian circuit. So let me define this. It is defined as a cycle that cycle passes to all the vertices of a graph. For whatever the vertices that in a graph, so it is defined as a cycle that passes to all the vertices of graph exactly once. So this point you have to be remember, exactly once, except the starting and ending vertex. Starting and ending vertices, that is the same vertex. This is a definition of Hamiltonian circuit. So we are saying that this Hamiltonian circuit is a backtracking method. We can solve this Hamiltonian circuit problem by using backtracking. So backtracking means we have to reach that node again. Okay. Then what are they saying? So the difference is, it is defined as a cycle that passes to all the vertices. We have to pass to all the vertices in the graph exactly once, except the starting and ending vertex. Starting and ending vertex we have to visit again. If you want, you can visit again. But the remaining vertices you have to visit only once. Okay. Means here we are applying backtracking. Means first we select one path. If you didn't get the solution for that path, again you go back and take another path. We are taking the path. We are not taking the vertices. We are just taking the path. We are just ignoring the path whatever we already visited. So once if we didn't get the solution, you just break down that path and again go back. That is a backtracking and find another path. Is a possible path. So in that possible path, all the vertices should be visited only once. So that you have to be remembered. Exactly once you have to visit all the vertices in that particular path. Now let us see the example for this Hamiltonian circuit. So let us take the graph as A, B, C, D, E and F. So this is the graph. Okay, this is a connected graph. Now let us draw the Hamiltonian circuit for this. So first we have to start from A. So I started here. So what are the vertices that are connected to A, B, C and D? So these are the three vertices that are connected to the graph. So if three are connected, we have to take only the B first, because from left side we have to we have to take the next element that is connected to the graph, A after B. So we have to take B as a starting node. Next starting node for A. So from this we have to be calculate. So this is from 0. Next path we are reaching from 1. So from B, what are the connected graphs? So the B has to be connected to C as well as F. Okay. So let us take, we are connected to C, B, C. So this becomes 2. From C, what are the adjacent vertices that are connected to C? A is already visited. A is the parent of B, and B is already visited. So B is the parent of C. So don't go back. So come here. So see the connected graphs that are not visited are D and E. Okay, so this is 3. Now coming from D. So D, A is already visited. So next coming to the next vertex to D is E. This is 4. So from E to F. So from F, if you go back, already B is visited in this particular path. So this becomes dead end. Okay. So again backtrack and come to E. So wherever we stopped here. So from E, what are the adjacent vertices that are not visited in this particular path? A, B, C, E. So in this particular path, the vertices that are not visited are D and F. So this is 6, 7, 8. So from D, you have to go back to A or C or E, but already visited those vertices in this path. So this becomes dead end. This is dead end and this is dead end. Okay, now coming to F. Okay, so from F, what are the adjacent vertices that are not visited? E. Okay, let me name. This is E. From E, the vertex that is not visited is from E to C. C to D. D to A. So 8, 9, 10, 11, 12, and this is the final vertex, the starting vertex. So from A we started and visited all the vertices and finally we reached A. Okay, so this is the Hamilton path. The concept for the Hamilton circuit is we have to visit all the vertices of the graph exactly once except the starting and ending vertices, that is the same vertex. The starting and ending vertex should be the same vertex. Okay, so the Hamilton path here is, therefore the Hamiltonian path is, Hamiltonian graph is A, B, F, E, C, D, A. Okay, so A, B, B to F, F to E, E to C, C to D, D to A. Let me draw here B, F, E, C, D and A. So this is the Hamilton path. So this is a given graph and this is the Hamiltonian path. Thank you.